So we mentioned telescoping or one-pot reaction sequences later. So what exactly are these? Well, this is running a series of reactions, possibly indeed in one vessel, without isolation of products or intermediates to reduce the downstream processing operations and reduce plant occupancy. So typically intermediates, reagents, catalysts are added sequentially. There may be a small degree of workup between charges of reagents and catalysts if these are incompatible with later chemistry, so maybe washing, crystallizing out, or removing a catalyst with a particular absorbent or resin. Now, telescoping is most efficient if all the combined processes can be run in a single solvent or a mixture of compatible solvents. So if we can, it's best to avoid solvent changes. To be really successful here, we need good analytical methods to quantitate yields and impurities. And when we're setting up telescoped reactions, we need to always be aware of the impact of impurities and byproducts that are carried through. And this needs to be appreciated as it can have an effect both on the quality of the product and potential inhibition of catalytic reactions downstream. As mentioned earlier, for cGMP stages, we need to be aware of having certain points of control. So we couldn't telescope an entire synthesis from starting materials all the way through to product. And just at the bottom of the slide, you can see a reference. This is a recent publication that highlighted some of the benefits of telescoping for a particular process. So they had one isolation rather than two, 24 workup and purification unit operations versus 49, reduced batch cycle time, and a good reduction in the cost of the materials. You're using far less resources and plant time to make 1 kilogram of product. So here we have a couple of examples of one-pot or telescope reactions. So the reaction at the top here, this was run from the starting materials all the way through to crystallizing the product out in one go, just by sequentially adding reagents and different solvents to a reaction mixture. Similarly, the reaction below took the starting materials through to this product just by sequential addition of reagents into one vessel. And at the bottom you can see some figures looking at the benefits of the telescope reaction to the original multi-step process used to make the material on the right hand side.